Hey, everybody.
Hey Jim, how are you?
Good. How are you doing?
Morning. Can you hear me okay?
Yeah, you're good. Maybe we give people another minute to join. Mike, is your presentation, you think we'll go the full hour?
No, I don't think so.
Okay. Yeah, I think right now you're the only item on the agenda. Is any other opens or agenda items people want to talk about today? No. Okay. I guess, Mike, when you're ready, if you want to go ahead and introduce your topic and then present.
All right, sounds good. Uh, Hold on. Okay, do you have the screen share?
Yeah.
Yeah, I
see
can
it.
see it.
Excellent. Okay, well, good morning, and thanks for having me here. I am Mike Stunes. I work at Microsoft on in the Core OS division in a team that we call Modern VM and Migration. And Greg, well, so what our team does a lot of things, but one of the things we do is a lot of the core work on the Paravisor, or what we call HCL, host compatibility layer components that we use in Azure VMs. And one of those important functions is the Azure VM specific bits of the virtual TPM implementation for Azure VMs. So Greg asked me here to talk about how we do, I guess on the topic of composite attestation, how we do attestation for virtual TPM and binding virtual TPM evidence to confidential VM platform evidence. So what I've sort of framed this talk around is, we have a VTPM. We can use the TPM and keys in the TPM to make claims about the state of what's going on in our confidential VM. So how do we actually prove things about that at the confidential VM layer itself? And before I get into that, I would like to just give a little bit of background information, especially about just the relevant bits of the Azure stack, just so we're kind of all on the same page and we know how these things are sort of implemented. So just so we all kind of know, like, we're talking about, I'm kind of a relative new guy in the TPM space. I'm learning a lot about this myself, but I know that one of the important functions we're talking about is the TPM quote, which is
Hey,
essentially,
excuse me,
yeah, go ahead.
Mike.
Yeah.
I don't know if other people are seeing this, but when you transition between slides, it like takes about 10 seconds where it's in this state where it's like a blend of the two. I don't know if you're seeing that
Oh,
on your screen or if that's like
I,
just some
that's,
artifact of Zoom and if
uh,
I'm the only one seeing it, then ignore it. But oh, I see saying yes for me too. So there's just
oh,
FYI, there's something about your
okay.
transitions that appear
That's,
like to be like one frame every 5 seconds trying to do a fancy transition. It's not working very well.
oh, okay. Well, darn. It's not a good time to try to go edit all the faves out
Yeah,
of the
but
presentation. So,
so
yeah, I'll just go slow on the transitions there, I guess.
yeah, don't go back and forth quickly. I think we'll
No,
just
yeah,
learn to live with it. But thanks.
this should be a one-way slide deck. So, and I forgot to say earlier, if there's clarifying questions or things of that nature, please feel free to just hop in. Discussion points I may just ask to hold to the end because I may get to it in the course of the presentation, but feel free to just jump in with questions if you have anything. So yeah, so the the function of, or one of the functions of the TPM that we're concerned with is TPM quote or TPM sign. So we have the TPM that has produced some state of our running system, perhaps, the bootloader, operating system, code, configuration, etc., saved in the PCRs, and then we can sign that with a key that lives in the VTPM and use that to prove the state of the system to some relying party. When we create an Azure VM, its virtual TPM gets an endorsement key and what we call the attestation key, the EK and the AK, provisioned in the VTPM. These are primary encryption and signing keys in the TPM's endorsement hierarchy. And the way this works is they're actually, I believe, for confidential VMs, they're actually provisioned in the VTPM inside of the confidential VM at its first boot time, essentially. So when the VM boots, and we'll talk more about the OpenHCL or the Paravisor architecture in just a moment, but we actually do that like TPM manufacturing process, if you will, from inside of the VM. It's not done by a central service in the confidential VM case. So that ensures that the key material that goes into the TPM is actually like it lives inside of the VTPM and doesn't escape the confidential boundary. And our confidential VMs, we use a Paravisor / host compatibility layer that provides, among other things, the virtual TPM implementation. Give a moment for the slide to settle here. Just to show how that architecture works, when we run virtual machines in Azure, we have a hypervisor, Hyper-V in this case, with a host OS and one or more virtual machines that are running some guest OS. And we use a feature of Hyper-V that is called virtual secure mode, which provides what we call virtual trust levels to create multiple privilege layers inside of the guest OS. And this is directly analogous to VMPL in SevSNP or TDX partitioning for TDX. And in fact, for confidential VMs, VTLs are implemented using VMPL. So you're actually getting different VMPLs in this case, or different TDX partitions. So we create the low privilege environment that we call VTL0 that runs the actual guest OS. And then the high privilege environment, which is VTL2 in our case, which runs our HCL. In this diagram, I've written OpenHCL, which is our new open source Paravisor implementation. And one of its components is the virtual TPM implementation. And the last piece here is we need a place to store the actual state of the VTPM. And one of the features of Azure VMs is, from the host point of view, there is what's essentially an extra disk that lives alongside the virtual machine, which is encrypted with a key that's kept in a key vault elsewhere and released into OpenHCL as part of the secure key release process, which ties into the attestation piece right when we launch the confidential VM. So that's sort of the architecture of the system in a nutshell. Are there any questions at this point?
Yeah, hello. I would like to ask one question on
Sure.
that was on the previous slide, but you don't necessarily need to go to back. So you were mentioning about the endorsement key, and I am trying to understand who is going to provide the seed for that endorsement key. Is it going to be provided by Microsoft, or would it be provided by someone else?
The seeds for those keys are generated inside of OpenHCL when the VM is basically the first time the VM boots. So when we launch a brand new Azure VM, the HCL layer is the first thing that boots before the guest OS gets launched. And it is created with essentially a blank VTPM state. And OpenHCL will see that the VTPM state is blank and then provision new seeds and then provision the keys from the seeds.
So
That makes sense?
understand? So do I understand correctly? You are saying that the seed will be provided by OpenHCL part.
Yes.
Okay, and it's going to be ephemerally generated within the OpenHCL?
Yes. It's not, I guess, what do you mean by ephemeral in this case?
I mean, so either it would be generated within or it would be provided by some external entity. And if it is generated within, it would be ephemeral, like a runtime generated key pair kind of. That's what I am thinking about.
Right. Well, it's generated by OpenHCL, but it is persisted. And the way that works is, again, we have an encrypted disk that belongs to the virtual machine, and the keys for that encrypted disk are tied to the confidential VM attestation. So that serves as the persistent store for the virtual TPM state. So it is generated by OpenHCL and then persisted into that data store.
Okay, I will wait for the discussion. Thanks.
Sure. Yep.
So just to follow on that, with the EK, is it using the TEE, the native TEE remote attestation to get it certified?
Yes, I think that that process is coming in about 2 slides.
Okay, all right,
Yep.
I'll wait.
Yep.
And I just want to see if I understand things correctly. I think at a high level, what you said was the first time of confidential VM boots, there is no VTPM state yet. There's no EK,
Right.
no AK, and the OpenACL code will generate a random key pair for both of those. And that then becomes persistent state in this VMGS encrypted file. But so there's, I think per what Osama was looking for was, is there any ability to control the creation of that key from an Azure customer's perspective? I don't know if that's what he was looking for, but that's how I translated it in my head. And if that's if that's what he was after, I think the answer is no. It is just, it is there. You can see in theory what is being done by looking at the OpenHCL source code on GitHub, I presume. But
Yep.
you can't control the actual code that's running. There's a build of it that Microsoft's created and is running, and it's a whole different discussion about how do you match the code that you see in GitHub to what's running in your confidential VM.
Right.
Thanks, Mike.
Yep. Thanks. Good questions. Okay, so with all of the context information given out there, I'd like to circle back to the scenario that we were talking about and just kind of flesh it out and nail it down a little bit. So let's say if I have some signed data or a signed quote from the TPM, how do I then prove that that TPM is in a confidential VM and what it is, what this key is that the information is signed with? How do I prove that the TPM implementation itself is trustworthy? And in this scenario, what are the actual roots of trust that I have to rely on? So this is going to be the diagram that I hope will be the answer to all of your questions from before. So we start with our TPM quote, which has our PCR state and stuff in it, which is signed by some attestation key. So what do we need to rely on here? Well, we need to rely on the trustworthiness of the TPM implementation to know that it's actually correctly producing PCRs. And we need to know what this attestation key is. So for the first piece, as I mentioned before, the VTPM is part of OpenHCL, which is the first thing that we load into the confidential VM. And as such, the OpenHCL is the initial state of the VM that gets measured into the platform's attestation report, which is itself then signed by a key that chains back to something provided by the platform vendor. So that platform key is essentially our first root of trust to ensure that the CPU is actually loading the OpenHCL that it claims to have done. At this point, this tells us what the OpenHCL running is, but it doesn't necessarily put any trust into that OpenHCL. And for that, we need another thing, which is a signed endorsement over the expected measurement of an OpenHCL. And what we do is currently every time we produce a known good build of OpenHCl, we create an endorsement with the expected measurement and sign that endorsement with our, I guess, HCl signing key. And I think Greg is probably a little more up on the details of what we do with these endorsements afterward. Because I know there is like a user-facing attestation service where you can verify these measurements, and Greg can correct me if I'm wrong, but I don't know what we do as far as like publishing a library of endorsements or what the plan is there. But
I think I summarized just it's in motion. It's going from historically a state of where it's not signed endorsements, it's baked into code like an MAA, to a state where it's officially signed endorsements, co-REM available for the different TE vendors. So it's in motion. The slide you have is, what we're in progress towards heading towards, and pieces of it are built out and pieces are still coming.
Yep.
So the attestation report, does it have how is it bound to the AK? Is it a
well,
hash?
that is where I was going next. Literally, what we do is actually include. Well, yes, it is. The AK, among many other things, is hashed and put in as additional data in the attestation report, and that is precisely what creates the binding between the TPM and the CVM evidence. So that is my chain of trust diagram. And as I was putting this together literally just last night, I also found this diagram out of the Azure VTPM developer documentation, which is public, and I have a link to at the end of the presentation, which is essentially the same diagram that I created earlier. So that is how we provide the binding between TPM evidence and CVM evidence. So this is another good place to pause for questions about the overall architecture. I have a couple slides next with a little more technical details of how we do that.
So one question I have in mind is that when you showed the endorsement that was signed by Microsoft, I believe Microsoft is not claiming at all to be outside of the TCP. Is my understanding correct?
Yes, and I'd like to flesh that out a little bit because, so Greg, I don't know what you know about any plans as far as, so I guess there's different parts of Microsoft that are or aren't in the TCP essentially. And I know I mean, like at one level, it's like, yes, Microsoft is in the TCP here because we sign the measurements of the OpenHCl, but there's like, the entire cloud host architecture, which is itself not in the TCP. Then there's the signing infrastructure for OpenHCl builds, which is in the TCP, and the key vault that holds the keys that encrypt the VMGS file that contains your TPM state, that is very much in the TCP, and so on. Greg, I don't know what you know about any plans to completely open source OpenHCl. There is an the way it is now, it's primarily open source with some closed source extensions that we build on top of it. And I know that's a little unsatisfying from a TCP point of view, but that's where we are today.
Well, I think you probably need two things, right? The OpenHCl is open source, right? So the idea that somebody could reproduce the measurement by building it, right? So you could prove that the endorsement, I think had MRTD, published by Microsoft, matches what's actually being loaded.
Right.
And the other thing that you would need to have the capability of going down this the cert chain to the root CA, so the vendor CA. So somehow that attestation key hardware report needs to be embedded in the VTPM quote. So you could audit it, and then you could you could follow it all the way back and say, yeah, open HCL is in my TCB, but I can verify that it's proper.
Right. I can look at the
Yeah.
TPM code myself and see what it's doing and
Yep.
produce the same measurement that I see coming out of my VM in its platform report. Exactly. Yeah.
Yeah.
But just to be very clear, I mean, I think there are still some components of OpenHCL that are not open source. One cannot independently of Microsoft generate a hash value that one can check. Correct me if I'm wrong.
Yes, that is correct.
Okay, thank you.
Yep. And like I said, I don't know what future plans are in that area.
Sure, I just wanted to be
Yep.
clear on
Yes.
there are some TCP components that one has to trust, so that answers my question. Thank you.
Yep, that is correct.
We have a couple hands up too.
Oh, sure. I'm my setup is such I can't see, so feel free to just chime in.
Yeah, I can monitor for a bit.
Sure.
Yeah, look at Hank has his hand up first.
Yeah, hi, this is Hank. So it feels to me like when there's part of the TCP, part of the hypervisor to be specific, that is opaque. So you have a module you're plugging in there for the Azure context. That's basically introducing another root of trust because it's an element that is you can measure and assume when you're saying endorsement, you provide a reference value for it to understand. Okay, that's the right opaque blob, but you can't see it, and therefore you trust it blindly.
Yep.
And that's the quality of a root of trust again.
Right.
So
that is,
somehow
that's
in the middle of the TCP stack, you're introducing a rod, which of course is okay, but also I want to say makes the T in TCP a little bit smaller, right?
Yeah.
So, I agree with Usama there.
Yeah. Yep, I hear that. Definitely.
Okay.
More hands?
Yeah,
Is there anybody
I
else?
think Jerry's next.
Yep, go ahead.
Yeah, thanks. Just interpreting this diagram, and if you don't mind, I'm going to relate it back to the S&P guest report, but
Sure.
But you can probably generalize it from there. I'm assuming when you have hardware port certify AK cert, that the guest is actually accomplishing that endorsement by providing the AK cert in the form of report data for the S&P guest report. So it's basically like guest provided data that the platform really doesn't interpret. It just puts it. It just goes ahead and includes it like it would challenge data and
Yes.
signs over it.
Yep.
Yeah. Okay. So in your previous slide, you had mentioned that the VTPMs run in VMPL 0. Is there
Yeah,
any
I'm gonna just
relevance to
back up to the slide.
Yeah, I think it was before.
Oh, yeah.
Yeah, yeah. You don't need to go to that.
Okay.
Do you expect the platform to actually enforce VM privileges with respect to retrieving the attestation report? So, for instance, if there's a rogue sub VM that tries to request an attestation report and purports itself to be a VTPM, is that something that you expect the platform to enforce, or is that
Oh, I
something
see.
that's enforced within the CVM itself? So,
Ooh, that's a good question. So you have to forgive me, my S&P knowledge is getting a little bit rusty, but the attestation report produced by the platform has the requesting VMPL in it, right?
it can. I don't
I
believe the
see.
current implementation does that today because
Oh, okay.
I mean there could be legitimate reasons for a lower privilege VMPL sub VM to actually retrieve a guest report, right? So
Sure, yeah. Hold on, I want to try and just find that slide real quick. Okay, so let me see if I understand this right, because I think this is a really interesting question. So what we have right now is OpenHCL will get a platform attestation report with the VTPM keys included as additional data and get attestation done with that report. And you're wondering, like, is it possible for like VMPL2 guest software to get an attestation report and include additional data that looks like a set of VTPM keys and then get that attested and do stuff with it?
I mean,
More or less.
right now, I think it is possible.
Yeah.
And I'm saying, is that a potential security hole for your model?
Sure. Yeah, that's a very good question. I'd have to think about that for a bit.
Yeah. Getting platform reports from the guest from the VTL0. My understanding isn't that locked down, and the only thing you can change in what we think of as report data is there's a subfield in there called user data. You can put your own, 64 or 128 bytes in for whatever you want, but the context of your hash that you could, if your 128 bytes you control from the guest or from VTL0 in this diagram, is you don't control the full report data. There's a hash of a structure that includes the measurements for the VTPM, the EK and the AK, and that's fixed. You can't mess with it. All you can put in is a subset of that. You can say, "Oh, I'm the guest, and here's my hash for something." Isn't that?
Well, I have a slide on that, and there's yeah. I guess what I was wondering is, like, I don't know, in SNP, is it possible for software running in VTL0 to just, or in like VMPL2 to just go get its own attestation report directly from the CPU without going through OpenHCL? Because I think the user data thing that you're talking about, Greg, that's essentially kind of an add-on feature provided by OpenHCL. But like, I thought, I don't actually remember now. Like, is it possible for VMPL2 to just go get a platform attestation report with whatever additional data it wants embedded in the report?
In my experience doing little, apps for these environments, just for kind of exploratory purposes and messing with things, when I'm running in Linux, I find that, like, in a confidential VM in the guest, I don't have, from a Linux perspective, I don't have the traditional device mapped into into that Linux device driver kind of file hierarchy. I can't actually do a set SMP report generation. If I go to a confidential container, which is architected differently, then I do find that device and I can go generate it.
Okay.
The only way to get a set SMP report in a guest OS is to do that funny business going through, the TPM itself and saying, poking the NV index kind of stuff.
Yeah, I think TDs, I can say you can't do that from only the layer 1. You have the VTL2 get a hardware report.
Okay. Are there any other hands up?
I have my hand up for a.
Okay.
I just wanted to. It's such a smart audience. They'll eventually call me or call us on it. There's discussions about drilling into, like, how do we trust OpenHCL? And on one hand, we're saying, oh, it's open source. On the other hand, as folks, I think Hank pointed out, it's kind of like, well, if you have this separate root of trust where you bless the measurement and, there's no reproducible build, so you can't, on your own reproduce that. It's ultimately the open source thing is it's also a trust thing. You're trusting that that's what's being built. We haven't, the comments point into this a little bit. I just also want to point out and acknowledge that dealing with the key to decrypt the VMGS file, right? Because if you can get the contents of the VMGS file, then you basically own EK and AK, and so everything around that and managing the key that can be used to decrypt it is then, I think, part of what we think was the TCB. And we have, Mike, you haven't gone into that part. I don't know if you will. I'm not saying we should if you don't plan to, but
not in this talk, but we can talk.
There's a whole bunch of stuff going on there. There's platform quotes. There's the MEA service itself, which is used to verify the evidence and give a token that's then used by a key management system to do an SKR and share that key. And so there's a chunk of code out there in a few different services that are also become part of this TCP, and all the questions of like, how do we, what are they? How do we, trust them? Are valid questions, and I think there's answers for them that they ultimately, I think, amount to more roots of trust. For example, how do you trust MAA amounts to a root of trust to a key that the MAA team manages and publishes with interested customers that can be used to validate the confidential computer environment that MAA runs in. But that's yet another kind of root of trust. At a high level, I think what I see happening kind of in my corner of the universe is we try to figure out how to help customers establish trust and address these questions about the TCP and how to shrink it and how to trust it. There's it's in motion. There's discussions about open source. What do we open source? What do we not open source? How do we do reproducible builds? And then there's also discussions about transparency and transparency of provenance of all these components. And so I just wanted to share, I don't have anything more to say about that other than there's active work going on in kind of all those areas to try to make these things clear, address concerns, but there's no holistic, complete solution yet. I think that makes everybody feel like this is great. And if you have thoughts and feedback and requests, certainly share them. That's great.
Yeah, thanks, Greg. +1 to all of that.
Yeah, a quick comment or a follow-up on what Greg said. So I completely agree with Greg. And as long as it's not made, as long as Microsoft is not claiming to be out of the TCP, it's all perfectly fine as long as things are transparent. That where exactly do we have to trust Microsoft for it? For instance, in the Microsoft Azure attestation part, for example, in the what was it called, the endorsement part and so on, and OpenHCL and so on. So as long as things are transparent, I have no concerns whatsoever, rather than making it let's say a very complex thing which nobody understands, and still people can claim that, hey, we are out of the TCP because of this whole bundle of thing which nobody understands. So I mean, just to clarify from my side, as long as things are very clear, which I believe in this presentation are made very clear, so I'm happy with it, that everything is clear, who we trust, and that should really be the goal, that we know who we trust, and that's it. And then the community can together try to find out what we can do better. And as Greg was pointing out, many things are going on and so on. Yeah, thanks for being clear about it.
Bet. Yeah, that's great. Thank you. Okay, so I have a few more.
I see one more hand.
Oh, all right, go ahead. Yep.
Shalini.
Yes, I have a question on the first slide where you show the key being stored encrypted in the database. So I wanted to check that, the seed of AK is exported out and it is stored in that database, correct?
Well,
The
yes,
seed which is used to generate AK.
correct. Encrypted with a key that we only release into the confidential VM.
So that key is also owned by Microsoft, or that is somehow tied to the platform, which is
It's
that seed.
yeah, it's let me can I draw on my presentation here? There's off in the cloud here somewhere, there's a service called Azure Key Vault. And that stores the actual keys here, and then those get released into the OpenHCL as part of the attestation process. So the Azure Key Vault itself is definitely like in your TCP. So the host, like the fleet of hosts that we run confidential VMs on, is not in the TCP.
Okay.
Is the
any
key,
reason why Azure you want to use Azure key vault for protecting the key and not use maybe the public key of the platform? Like maybe the key that is exported is already wrapped with the public key. So and that can be used for storing it in the database rather than using the Azure key vault.
Are you talking about like the confidential platform generated keys.
Yeah.
I think
Yes.
we are actually working on support for doing that. So we have like, I guess what we call stateless VMs that can, well, they're kind of like almost stateless VMs, I guess, where they do actually just use platform generated keys to encrypt the data that goes into the VMGS. The problem is then you're locked to a specific host, and we try to, for VMs running in the cloud, try to preserve migratability and things like that. And other like, OpenHCL upgrades and things that would otherwise affect measurements that would go into a platform generated key. But we do have support for doing that. Greg, were you going to say something there?
It's not important. I see one more hand and a question in chat that's probably worth discussing now. Oh, the other hand went down. I see a question in chat from Yash. It says, question for Mike. Does OpenHCL have plans of adding support for SVSM?
I don't know.
I don't even know what SVSM
that's
is.
the AMD's thing for running stuff in upper VMPLs and then providing like if you have an enlightened guest OS, there's a particular interface they've designed so that the guest can like interact with high privilege like VMPL 0 code.
Yeah. By the way, that's a Linux Foundation project.
Linux Foundation. Okay.
Yeah, you can't. It's not just AMD, although we
Right.
have a big role in it. But
right.
yeah, that's
it's
right.
for
It's
SNP though.
yeah, it's not. It also does, among other things, it's something we've been discussing here quite a bit, which is migration of confidential workloads and confidential VMs between machines. So SVSM is actually engineered for that. But yeah, you can, it's an open source project, and you can look, you can look at.
Yeah, so OpenHCL is not an SVSM right now, as I'm aware. As far as I know, I don't know what the plans are. I know like one of the goals of SVSM was to provide like standardized interfaces into VMPL 0 from an enlightened guest, right? Anyway, but I was going to say like our OpenHCL interfaces to the guest OS in our system using what look like just kind of standard virtual device interfaces.
I think Azure doesn't support SVSM for Windows Server implementations. I forget the name of what you're using instead. So Azure supports two as far as two different confidential VM. It kind of CVM security engines. So.
Yeah, Nathan has to hand up.
Yes, sorry, the last time I had my hand up, I was talking and my microphone was on mute.
Whoops.
Sorry about that. First of all, thank you for this presentation. I think, so I was looking at the Coconut SVSM project, which Yash, I think, just also pointed out. I believe that works currently primarily with AMD, but it looks like the solution that you have with OpenHCL works with, should work, looks like, with Intel also. Do you know if the OpenHCL paravisor can integrate with QEMU or other KVM-based hypervisors, or not really?
Oh, that's a good question. I seem to recall that somebody was working on VTL support for QEMU. which would probably enable using OpenHCL and QEMU. I don't know what the state of that is currently, but that's a good question.
Okay, so I'll follow up on that one. VTO support.
Yeah, I'll write down some of these to go follow up on.
Okay, and just if we have like 1 extra minute, just curious, on the page you described the Azure Key Vault. Is that a service that the customer purchases? So it's something that the customer owns?
I mean, it's Microsoft managed in any case, but there's like varying levels of ownership, I guess. I think at one level, it's essentially I don't know a lot about the architecture of Azure Key Vault. It's like kind of from my point of view, it's a service out there where you present a token and you get back a key. And the token is produced by, in this case, the token is produced by Azure Attestation, based on the attestation report that the confidential VM produces. So I think at one level, it's just kind of like a fully managed, you get an API endpoint where you present a token and you get back a key. At another level, there's our managed HSM service where I don't know how dedicated it is, but you get some level of dedication with like an actual hardware HSM. Managed by us, but hardware HSM. So yeah, I can try to find a reference to like the Azure Key Vault documentation and send that out. I think somebody asked for that in the chat there. So
okay, thank you.
I have I think a related question. So Key Vault is a key management system and secret management system, and as you mentioned, it has various flavors. Some that are where the keys are in HSMs, and some where they're software managed separately. From this scenario's perspective, as you point out, there's a key. There's a key in Key Vault, and it's the key that's used to encrypt the VMGS file. Is that key managed by Microsoft in all circumstances, or can an Azure customer say, "Hey, for my confidential VM, I also, I have my own Key Vault. I created it in Azure Key Vault, but conceptually, I have management privileges to it, and I want, my VMGS file and my CVM to use, my Key Vault key to do the encryption. And yes, I'm still trusting Microsoft and so on, but I have a little more visibility, and maybe if I want to, I can, basically, in an emergency situation, delete the key in Key Vault and then hopefully that, kind of assures that the CVM can't boot anymore, kind of thing. Is that, do you happen to know if that's supported, or is it purely Microsoft managed keys in Key Vault?
Well, so we have this notion of what we call platform managed key or customer managed key. I mean, even in the platform managed key basically means like we provide the cloud, the Key Vault instance, and we provide the key release policies and all of that stuff. This is confidential VM specific. Key Vault itself is basically like a generic secret store, but we use, this is CVM key release is one specific application. And for CVM specifically, we have platform managed or customer managed key. For customer managed keys, like it still lives in the Microsoft provided Key Vault service, but you can define, like you create the keys and you define the key release policies and that sort of thing.
So it doesn't change the TCP. Key Vault's in the TCP, the attestation services in the TCP, but a customer has access to the levers, right? And they can see the specific key, and they can, if they, for some reason they still trust Key Vault, but not MEA or CVMs, they could
not
like
our
go
policies
and turn
on top of Key Vault, perhaps. Yeah.
Pardon me?
I said trust Key Vault, but not our policies on top of Key Vault, perhaps.
Yeah, or something like that. Yeah. Okay. Thanks.
Yeah. Okay. So go ahead.
If a relying party wanted to audit all of these trusted flows, Key Vault and the AK attestation, is that available?
I don't know.
Audit might be I worked on Key Vault previously. I was actually on the team that created it at the beginning of time. So I have a little knowledge of what's going on there, and I work on the Azure Attestation Service now. And both services support if both services support customer-facing logs. So if you own any resources in Key Vault, you can configure it to generate logs, in wherever you want, somewhere within Azure, but you can select where you want. And the same thing with if you own what we call a custom provider in the attestation service, you can also basically say collect logs and put them like in my Azure storage or what have you. So I hesitate to use the term audit because audit has, specific and sometimes slightly different meanings for folks. But there's if you can configure this to use your own Azure customer owned Key Vault and your own Azure customer owned endpoint in the attestation service, you can then collect logs and export them, report on them, etc.
Yeah, I think probably like the farthest I know you can go right now, and maybe I'm wrong about this, is I think at one extreme we have the like Azure managed HSM service where you, I don't know, quote unquote, own a hardware HSM, or you rent it from the cloud essentially, but I think it's some level of dedication, and I think you can use that as a backing store for your CVM keys. And then the logging and things that Greg was talking about. So we're past quarter till here, so I have just a few more slides I want to zip through real quick, and then we'll swing back around at the end. So when we were looking at the chain of trust diagram, I had mentioned I was going to say a few more technical details about the attestation report and binding and stuff. So I'll just kind of give a little more technical flavor here. One of the features that OpenHCL provides in its VTPM implementation is a way for guest software to access a hardware attestation report. And essentially what we do is get a report and then save it into a TPM NVRAM index that the guest can just read. And so what I put here is just a snippet of the OpenVMM code with a link to it on GitHub that just has the structure of this report. And what I'll point at is we have our own header that we define, the contents of the platform attestation report itself, followed by additional runtime data that's produced by OpenHCL. And the hash of that data is included in the platform report as additional data. And to expand on that, let's see, there we go. This is an example structure of the user data or the additional data that OpenHCL would produce and include in the platform report. And so the first thing is the TPM keys themselves. This is the actual public parts of the AK and EK that we've provisioned. And then the next part here is what we call runtime claims. And this is information about how OpenHCL has been configured to run in this particular confidential VM. So like these are configuration attributes that are not hard coded into OpenHCL. They're configured by what the VM wants. And so we have like serial console, secure boot, VTPM support, and then this is actually the BIOS GUID of the VM, which is the same data you'd see if you look for the like DMID code BIOS UID inside the VM. And then finally, this is the field that Greg was mentioning. There's an additional user data field that we've provided. And the way this works is software inside of the guest can write whatever data it wants to another NVRAM index in the virtual TPM, and then that gets reflected in this slot in the attestation report. One more little piece, because Greg had mentioned to me in a previous talk, somebody had asked if the certificates in the TPM are signed into a certificate hierarchy. We do produce a certificate for the AK itself, which is then signed by the Azure Virtual TPM CA. So the process for this depends on the platform attestation with the report with the AK and EK baked into it. And this certificate is made available to guest software in another TPM NVRAM index. And I put a link in the slide here to the CA certificate bundle that we provide. It's probably not in your trust store by default, but it's available. Let's see, I've collected a bunch of resources that I think will be of interest to people after this talk. The first two are for the OpenHCL open source code. I have a link to the GitHub repository and a link to our public developer website. Right now, I don't know if I mentioned, but we have 2 different HCL implementations in Azure right now. We have the older proprietary one that we call the legacy HCL, and then we have OpenHCL. Right now, OpenHCL is in use for the TDX public preview in Azure and some subset of what we call our trusted launch VMs. So trusted launch is where we have an architecture that's kind of analogous to what I showed for confidential VMs, except for VMs that are not confidential. We've just moved some of the bits inside of the VM trust boundary anyway. So I put a link here to Azure documentation about the TDX preview. There's a tutorial I found from Intel about using their Intel Trust Authority to verify attestation reports from Azure TDX VMs. So I thought that might be of interest. We've published a fair amount of example code about how to do interesting attestation things from inside of the guest. And then finally, I linked to the documentation for the Azure Attestation Service itself, and then some developer documentation for how we've designed the attestation for CVMs. And this has detailed documentation about how to use these TPM entries and things like that. So what I wanted to show is just show our architecture and show how we've bound the TPM to CVM evidence by using the platform attestation report. And we've gone through the roots of trust, which include the platform vendor key, Microsoft's HCL signing key, and optionally the virtual TPM CA for the CA hierarchy that we include the TPM keys in, as well as we've discovered through the talk, other services like Azure Key Vault and Azure Attestation and our remaining closed source OpenHCL bits. So that is what I've prepared. So thank you for all the great questions along the way. And I guess in the last few minutes, we can continue discussing.
Yeah, thanks, Mike. That was a really good discussion.
I'll just zip through the chat here. Yeah, I'll share the slides afterward. Let's see, I linked documentation for Azure Key Vault somewhere in the chat, up a bit on Mohammed's question. Let's see, does AKV have any dependencies on platform key derivation services? That's a good question. I don't have the answer. I don't know if Greg knows that one.
I think AKV is, at least when I last left it, it does its crypto stuff either using software in the host OS or using HSM hardware. So it's not doing any like crypto key derivation stuff using. I think the answer is no.
Okay.
All right, thanks.
And Greg, you've got your hand up.
Oh yeah, and this is actually a question for, I think, the audience. I think I heard, like in the first 20 minutes somewhere, I think I heard somebody mention or ask a question like, do you have a TPM quote that signs the platform evidence? And maybe I misremember, but if something of that flavor was asked, and I think the answer is no, the signing happens the other way. The platform evidence essentially signs some data from the VTPM. I want to understand more of what folks were thinking about that and why that would be important or useful. I think that's related to your last thing there, other patterns of approaches for VTPM attestation. Yeah. Do you recall somebody mentioning that, Mike, or is that
I don't remember.
Or somebody, or maybe I just misinterpreted.
Is this the TEE attestation report signing the AK?
This was, I thought I caught somebody asked something about, is there a VTPM? Is there some, did the VTPM sign the platform quote or something like that? Or is there some measurement of the platform quote in the VTPM PCRs or something like that? And that's what I'm trying to see if there's, because now the chaining goes platform evidence, chains to VTPM keys, chains to whatever, right? And I'm just wondering, is there some thought of going the other direction, like VTPM chains to platform quote or report that then,
I mean, that can be handled all within the CVM, right? The CVM can obtain a platform report, extract the hashes of what it wants from that platform report and store it into PCRs. The only thing is it won't be signed by the platform,
I
but
think,
there's no, yeah.
let's see.
Well, the NVRAM index had a field that contained the TEE attestation report,
Right.
right?
Yes. That's not really like a certification chain or anything, though. That's just like we get the report and we put it there to make it available. So that's not like.
But it has the hash of the attestation key in it.
It does, right?
Right. Okay. So that's the chaining.
Yeah, but that's signed and certified by the platform key from the confidential platform. So it's not like that's not signed or certified by the TPM in any way.
No, that'd be kind of circular, I think.
Yeah, so I think like we have an arrow here where like the hardware report will certify the TPM quote. Like we have one arrow, and I think Greg is asking, is there another arrow that goes this way? And I think the answer is no.
Yeah, or is there reasons to consider a design where the arrows flow the opposite direction?
Yeah.
You know, and I haven't thought about this in any detail. Just I'm not. It seems like the answer is no. Nobody's jumping up and down saying
I don't know if
this is backwards.
I don't know if you gain anything from that.
I'm just in enumeration mode, just trying to
sure.
figure out. You know, I'm not at all the mode at the point of like saying, does this make sense or not, or how much sense does it make? Just
right.
All right, thanks.
Yeah, good question though.
On a related note to what, so on a related note to what Greg was saying, I was also wondering on the last slide when you were mentioning like other possibilities or something like that. So I was wondering if you have already within Microsoft had this kind of discussions on what could be the possible alternatives or approaches, or if there was any discussion at all.
If there was, it probably predates my involvement. So I don't know. That's a good question though.
Right, thanks. And one quick question. So I think that at least I couldn't find this level of detail in any of the public documentation available. So I was wondering if that is available somewhere, or you had written it down somewhere in some form.
Documentation about what in particular?
So about like the technical details, of course, there is a lot of like user level details, how to use this technology. The other part of this that you presented, like who is presenting, who is owning which key, how is the key flow going on, like what is Azure doing, who is, so I mean, the technical details, of course, you will share the slides, but I was wondering if that is written down somewhere at all, or this level of technical detail or not.
Yeah, I think this last link in the resources of the guest attestation design documentation is probably the most technical one you'll find. And that's actually, I think that link is where I got one of those diagrams from. I hear what you're saying. There's like a lot of documentation that kind of focuses on using it, but not so much about where these things come from. But I think this guest attestation design documentation is probably the most relevant or closest to that. Let me see if I can find that real quick.
Sure, that's fine. I will follow up with you later
Sure.
on. So thank you. That
Yeah,
was
yeah.
already very helpful.
I
Thanks.
think
Yes,
this is
good,
it right
quick-
here.
Quick time check. I think we're 1 minute over now, but
Yep.
might be start dropping people here.
Sure. I mean, I can
But
stay a little
again-
longer if people are interested still.
Okay, sure.
Would love to have you back at some other meeting time as well, so we can digest this kind of stuff and maybe have some follow-up questions. That was already
Sure.
very useful.
Sure.
So it would be great to have you back as well.
Do we,
Yeah, appreciate it.
Thank you.
does it make sense to consider in 2 weeks? Because I think there's nothing scheduled in 2 weeks, and thoughts are relatively fresh. Or is that something you'd want to see like in a handful of months, Osama?
I think 2 weeks would be great. So if the slides are shared like in a day or two, so 2 weeks would be a good time. I would love to have a follow-up on this.
Does that work for you, Mike?
I will have to find out. I mean, I can probably make it work. So let me find out though, for sure. I'll try to get back to you on that within
All
a
right.
day or two.
Sounds good.
I'll just leave my email in the chat there if people want to, because I don't know, I don't know what I'd talk about in the next 2 weeks time. So if you have specific things you want to know more about, please feel free to.
No, I think it would strictly be any questions.
Oh, sure.
Answer questions. It might take 1 minute. It may take an hour. Probably, and
sure.
Yeah, go from there.
Cool.
That's what I would say. Yeah.
Yeah.
Okay, thanks.
All right.
Just
thanks,
one.
everyone.
Yeah, thank you. Just one clerical. Greg, are you next in the lineup?
I'm on point. That's why I want Mike back.
Okay. All right. Great. Hey, thanks everybody.
Thanks.
Well, thanks everyone.
Thanks a lot, Mike.
Take care.
Yep.
Bye.
Bye.
Bye.